Hello everyone, welcome back to the next session in light reflection and refraction of grade 10. So in the previous session we were learning about the plane mirrors, spherical mirrors, basic terminologies of the spherical mirrors, and we also learned about the rules of the ray diagrams that we need to understand. So that rules in ray diagrams will be helpful for you in the image formation of today's class. So we will be doing image formation of concave and convex mirror in today's class. So we'll start with concave mirror. So please be sure that you have seen the previous video so that you understand the rules and for the ray diagram. Okay, so we'll start with concave first. Concave mirror, we have 6 cases in the concave mirror and 2 cases in the convex mirrors. So we will be dealing with the object distance, image distance, and then the size, and then the nature of the object, whether it is real, diminished, or it is virtual, erect, all those things we will be seeing in the nature. And where we keep the object, where we get the image will be the object distance and the image distance. So we'll start with the first one. Now our object is AB and the image will be A dash B dash. Okay, so object, I have kept my object at A, B, that is at infinity I have kept. So my object is at infinity. When my object is at infinity, the first rule in ray diagram, the light from the object goes parallel to the principal axis. Okay, so this is principal axis, we know, and when the rays are parallel to the principal axis, what happens after the reflection? Good, it goes through F, the focus. So our image will be formed at F. Good, my image is forming at F. So then what about the size of the image? What size can you see? It is point size, so it is highly diminished. It is point sized. Okay, so my size of the image is point sized. And what will be the nature of the image? Will it be real, virtual? It will be real and inverted. Okay, it will be real and inverted. Okay, this is the first case. When I keep the object at infinity, my image is at the focus. Now let's go to the second case. When I go to the second case, I just keep my object from infinity, I take it closer to the mirror, I keep it at F. So my object is at F. When my object is at F, there are 2 rays that are from the object, the 2 light rays. One is that is parallel to the principal axis, that is your BD is the parallel to the principal axis, this one, and then after going parallel to the principal axis, the reflected ray will come through F. So this will be the ray that is coming through F, and there is one more which is going through C, passing through C, the center of curvature here. So when it passes through center of curvature, what will happen for the reflected ray? Yes, it will again pass through the center of curvature. So when these these 2 lines after reflection, one from the through the focus and one through the center of curvature, they are parallel. What happens when parallel lines when coming together? Do they come together? Do they join? They join at infinity. So my image is formed at infinity. Okay, my image is formed at infinity, and my size of the image will be enlarged. Okay, it will be enlarged and it will be again real and inverted. Okay, so can you see the difference? Can you find out anything similar? So when I keep my object at infinity, my image will be at F. But the opposite is the second case. If I keep my object at f, it will be, my image will be at infinity. Good. So just the opposite of the first case is the second case. Okay. So we'll move on to the next one. Third and fourth case. We'll move on to the third and fourth case. Now I keep my object between infinity and C, or I can say that I have kept my object beyond C. Okay, I have kept my object beyond C, the center of curvature. So there is one line passing through, one ray passing through the center of curvature, it will again go back. Yeah, and there is one line parallel, one ray parallel to the principal of principal axis, and which will come through principal focus F. When they both meet, they meet between F and C, or C and F. My image will be A dash and B dash, as already I told you. So my image will be formed between C and F, between my center of curvature and principal focus. So what is the size of my object and what is the size of my image? It has gone down, it has been reduced. So it is diminished, it is just diminished. Okay, it is just diminished. What is the nature of the image? Real and inverted. Real and inverted will be the nature of my image. Okay, now we will move on to the next one. My object is between, good, it is between C and F. I have kept my object between C and F. So where will be my image? Beyond C. Very good. It will be beyond C. So if it is diminished here, it should be enlarged. Good. Enlarged. And then real and inverted would be the same. The nature would be the same. Okay. So you can again see the opposite of the third case will be the fourth case. When I keep my object at beyond C, and my image will be formed between C and F, the vice versa of this will be the fourth case. So I keep my object between C and F, my image will be beyond C. Okay. We'll move on to the next case, fifth case. If you see the object is at C, good, at C. So there are two lines, there is two lines, two rays, that is one is through the focus itself and one is through the, one is parallel to the principal axis. So when it is through the focus, it will be parallel to the principal axis, and when it is parallel to the principal axis, it will go through the focus. So when both these lines after reflection meet again at C, okay, when you keep the object at center of curvature, the image will be also at the center of curvature itself. So the size will be the same size. There is no change in the size. The size will be the same. The size of the object and the image will be the same. Again, it is real and inverted. Again, it is real and inverted. But can you see, is it the opposite of sixth case? Is it the opposite of the fifth case? No. So now we will have to study this case separately. Okay. So my object is between P and F. Good. Between P and F. When my object is between P and F, what happens? My image is beyond the mirror, or behind the mirror. My image is behind the mirror. What can you see, the image and the object size? Good, it is enlarged. and this is, can you see the difference? I have drawn the real and inverted image like this, but the image here is virtual and erect. Good. It's virtual and erect. So from the first case to the last case, what I'm doing is I've first kept the object at infinity, and I have slowly been moving my object from infinity closer to the mirror. Good. So at the last, I place my object between F and P. So when I place my object between pole and our principal focus, my image is formed behind the mirror, which is a virtual image. Okay, I hope you understood the 6 cases of concave mirror, and then we'll go to the 2 cases of convex mirror. So, yeah, so this is the convex mirror. We know that pole, focus and center of curvature are here. So the first case, my object is at infinity here. When my object is at infinity, my image will be good. It will be formed at F. But in this case, if you see, there is no image forming at F, but when we keep a mirror or a screen this side, we will be looking at the image. So it will be again diminished, or it will be point sized, diminished or point sized. But the nature of the image formed by convex mirror will be virtual and erect. Okay. Now we'll move on to the next case. Now I keep my object between infinity and my pole. Between infinity and pole P. So if it is between infinity and pole P, my image will be between P and F in the case of convex mirror. Okay, so then it is again diminished, as we know from the image. It is again diminished, and again it is virtual and erect. So can you see the difference between concave and convex mirror? Concave mirror produced, all the 5 cases in the concave mirror were real and inverted, but only one case was virtual and erect. But the 2 cases of this convex mirror is virtual and erect. So you can say that convex mirror produces only virtual and erect images. Yeah. So with the basic of this, we will move on to the problems. So yeah, some of the questions here. An object is placed at the center of curvature of a concave mirror. The distance between the image and the pole is. So this is again a question from the previous session as well. So what will be the distance between image and the pole? When it is kept, the object is kept its center of curvature. When you keep the object at C, the image will also be at C. So it will be R, the radius of curvature, or you can also say that is it is twice the focal length. So R, which is also equal to twice the focal length. Yeah, R is equal to 2F. If the image formed by a spherical mirror for all positions of the object placed in front of it is always erect and diminished, what is the type of mirror it is? So it is both erect and diminished. So it will be a concave mirror. It's a concave mirror. If it is only erect, what will be the mirror? Good, it's the convex mirror. Yeah. So next, a concave mirror is held in water. What should be the change in focal length of the mirror? What will happen if it is kept in water? Will there be a change? There will be no change because we are using mirrors. Mirrors do not change with the medium. Okay, there is no change in the focal length of the mirror. No change. The focal length remains as it is, remains constant. Okay, for the mirrors. But when we come to lenses, we will see what will happen. Yeah. Okay then. So we will finish this session here, and we will move on to the sign convention, mirror formula and magnification in the next session. Thank you.